This is a problem from the homework that we went over in class on Thursday, but I'll run through it again so you have a point of reference if you had questions about it. We're trying to calculate the mean and median for data that is described to us in a summary form, and so we have to think about, maybe the way to think about it is what do you wish the data looked like in order to do these calculations, and if you sort of think about how you wish it looked, then you might be able to figure out what to do with it. This data consists of 4,362 pieces of data that were just either their answers were 0, 1, 2, 3, or 4, because the question was how many people do you personally know who are victims of homicide, which you hope most people would say 0. But this was the data that was collected, and so but this is just a summary of it. And so what the data actually looked like is the actual responses, if I list them, would have been 0, 0, blah, blah, blah. So a whole bunch of zeros, 3,944 zeros, and then a whole bunch of ones, 262 people said 1, 96 people said 2, 40 people said 3, and then in the table they've just said that 20 people said 4 or more. And so in the problem it says that we should interpret the 20 people who said 4 or more as just saying 4.5, that they would have said 4.5. So it's kind of a weird thing to do, but we do need this to be numbers. We can't actually have a data entry say 4 or more, so we have to do something with it. And so so for a lot of reasons that's a fair thing to do, but you always have to be upfront with that you're saying I don't have all the data and so I'm filling this in or something like that. So oops. Right, so here's our here's what our list of data would look like, sorted from lowest to smallest, and we know that, for example, for the median calculation, that's exactly how we would want the data sorted. So let me do B first. For the median calculation, I need to know where the middle of the data is, and so I should be able just to take the number of pieces of data and divide by 2. So there are 4,362 pieces of data. The halfway point would be the 2181, I guess. So the 2,181st piece of data would be one of the middle values. But if you look at the data, let's see, that's going to move with me, that's going to bother me. If you look at the data, the 2,181st person in this list is somewhere in here. So the 2,181st data entry is somewhere in this sea of zeros. And so what that means is that the median value is just 0. Now, so the median is easy if we can imagine what the ranked list looks like. We talked about that in class, that the positional information about pieces of data is actually easy and doesn't require a calculator for the most part. But we do have to imagine what the data looks like from smallest to largest because it's not given to us that way in the table. Now, the mean requires that we add up all of the numbers and then divide by the number of values. So it's going to be the sum of all of those values divided by 4,362. And when I say all of those values, I mean all of these values. So the sum of this whole list of numbers divided by 4,362. So finding the sum also is hard if you're only looking at the table, but it's not hard if you look at the list of data written out this way. If I really imagine myself adding up all of these numbers, well, obviously all of these zeros added together is just 0, and then all of these added together, adding 1 262 times gives you 262. Adding 2 plus 2 plus 2 92 times would give you a sum of 2 times 96. Adding 3, 3, 3, 3 40 times will give you 3 times 40. So in each of these categories, it's very easy to say what those numbers add up to. And so my sum is just going to be the sum of my 1s, which is 262, plus the sum of my 2s, which is 192. That's these guys. Adding 2 96 times gives me 192. The 3s are going to add up to 120. again, because I'm adding 3 plus 3 plus 3 40 times, so 3 times 40 is 120. And then these 4.5s added 20 times is going to add up to 90. That's just 4.5 times 20. So that's how I'm going to calculate my mean, is by adding up all the values on the right-hand side list and dividing by 4,362. And so that comes out to be 0.15 rounded to 2 decimal places. And we expect that to be low. We're averaging, this is supposed to give us an idea of the typical number of homicide victims you know personally. And so you would think that would be close to 0. And so it's not so strange that that happens. This last question, if a whole bunch of data, 1,744 observations, shift from the 0 category to the 4 or more category, how does everything change? So you can just literally do that. It's just going to change these numbers. The number of 0 entries, the number that was up there, is going to be 1,744 less of those, and you're going to put 1,744 more of these things on here. But it's very easy just by changing the 20 and the 0 to the other numbers. It's easy just to do the calculations again. So even if you're not sure, even if you're not sure where the what it means in theory, you can just repeat the calculations and see how everything changes. So for example, the median is going to stay the same because there are so many zeros that you're still going to be, the middle of your data is still going to be 0. The mean, on the other hand, is going to get a lot bigger because when you add up the numbers, when you add up these numbers over here, obviously the 0 part doesn't change no matter how many zeros there are, but this number is going to get a lot bigger if instead of 20 things you have 1,944 things. So you can tell that certainly the mean gets larger, and because this position of the middle value is still in the sea of zeros, that's not going to change. So you don't really have to do the calculation again. You can tell, but it is easy to do the calculation again if you're not seeing the insight into it. So anyway, so this is what actually happens if you redid the problem, moving 1,744 of these numbers down to this list.